Today we will presenting about the topic of lime products, whiteware products, and fuel products. Please enjoy the presentation. The first topic we talk about lime products. What is lime? Lime is an inorganic material primarily composed of calcium oxide and hydroxide. It is derived from limestone, which is a sedimentary rock composed mostly of calcium carbonate. When limestone is heated to high temperatures in a process known as calcination, it produces quicklime or calcium oxide. Lime is widely used in various industrial, environmental, and agricultural applications, including water treatment, soil stabilization, and as a key ingredient in cement and mortar. Lime can be further processed into slag lime or calcium hydroxide by adding water. There are different types of lime, including high calcium lime, which is mostly pure calcium carbonate, and dolomitic lime, which contains magnesium oxide in addition to calcium oxide. Type of lime. The lime have three main types of lime, such as the first is quicklime, the second is slag lime, and the third is dolomitic lime. This is the lime cycle. The lime cycle describes in the chemical process that lime or calcium oxide undergoes as it is produced, transformed, and returned to its original state. The following section will cover the details of the three types of lime, starting with quicklime. Quicklime. What is quicklime? When a calcium limestone or chalk rock that comprise mainly of calcium carbonate is heated in a kiln, it changes by a process called calcination into quicklime, also known as burnt lime, and chemically is mainly calcium oxide. And the calcination process releases a gas from the rock, which is carbon dioxide. When water is carefully added to quicklime, a chemical process called hydration or slaking occurs, producing bihydrate lime. This exothermic reaction releases significant heat, which can cause water to boil, evaporate, and even start fires if in contact with combustible materials. The steam emitted from a hydration vessel at a lime work is due to the reaction operating around 100 degrees Celsius. Dolomitic lime is a type of lime that contains both calcium carbonate and magnesium carbonate. When this type of limestone is calcined or heated, it produces a mixture of calcium oxide and magnesium oxide. This type of lime is particularly useful in agriculture, where it is used to neutralize acidic soil and supply both calcium and magnesium, which are essential nutrients for plant growth. Dolomitic lime is also used in various industrial processes, including steel making, water treatment. Applications of lime. Number 1. Construction. Cement production. Lime is a key ingredient in the manufacture of cement. Mortar and plaster. Slag lime is used in making mortar and plaster for building construction. Soil stabilization. Lime is used to improve the stability and load-bearing capacity of soils in road construction and foundations. Number 2. Water treatment. pH adjustment. Lime is used to adjust the pH of water and wastewater, making it less acidic and more alkaline. Softening water. It helps in softening hot water by precipitating calcium and magnesium ions. Flocculation. Lime aids in the flocculation process, which helps remove impurities from water. Number 3, agriculture, soil amendments. Lime is widely used to neutralize acidic soils, improving soil quality and fertility. Nutrient supply. Dolomitic lime supplies both calcium and magnesium, which are essential nutrients for plants' growth. Applications of lime. Number 4, industrial applications. Steel manufacturing. Lime is used as a flux in steel production to remove impurities such as silica and phosphorus. Glass production. It is used in the manufacture of glass where it acts as a stabilizer. Paper industry. Lime is used in the production of pulp and paper, particularly in the costicizing process. Number 5, environmental applications. Flue gas treatments. Lime is used to remove sulfur dioxide from the emission of power plants and industrial facilities, reducing air pollution. Waste treatment. It is used in treatment of industrial waste and sewage sludge to neutralize acidity and reduce odors. Number 6, chemical production. Calcium compound lime is used to produce various calcium-based chemicals including calcium carbide, calcium hypochlorite, and calcium chloride. Neutralization. Lime is employed in various chemical processes to neutralize acidic conditions. And the last topic we talk about hazards and toxicity to the body and precautions of lime. Ingesting industrial grade calcium hydroxide may result in calcium hydroxide poisoning, which can lead to severe injury or death. Symptoms of calcium hydroxide poisoning include loss of vision, severe pain or swelling in the throat, burning sensation on the lips or tongue, burning sensation in the nose, eyes, or ears, difficulty breathing, stomach pain, vomiting or stool with blood, unconsciousness, or low blood pressure. Therefore, if various food industry are to use calcium hydroxide or lime, they should use food-grade products that are safe for consumption. Skin and eye contact. Calcium hydroxide can irritate the eyes, skin, and upper respiratory tract. If there is direct contact with the chemical, it may cause bumps and blisters on the skin. Precaution. To safely use calcium hydroxide or lime, it is important to prevent skin and eye contact with the substance. If skin or eye contact occurs immediately, rinse with clean water. The affected person should be moved to a well-ventilated area, and medical attention should be sought immediately. The next topic, we will talk about the whiteware products. What is whiteware products? Whiteware is a term used in ceramic manufacturing, referring to ceramic products that have a clean white color. These are typically made from kaolin, the fire at high temperatures to produce durable and high-quality ceramic material. Whiteware is generally used for making various types of containers. Ceramic refers to objects or any items made entirely of clay or with clay as a component. These materials are molded or shaped into various products, then left to dry before being fired at a temperature high enough to make the items strong and durable, resistant to breaking easily. This type of ceramic has been continuously produced from the past to the present and is commonly referred to as traditional ceramic. The raw materials for this product may not be limited to clay alone but can include products made from inorganic materials such as various mineral nonmetals or a combination of different materials. These are referred to as modern ceramic. The ceramic production involves the following steps. Number 1, raw material preparation. Number 2, forming. Number 3, drying. Number 4, piece firing. Number 5, glazing. Number 6, glaze firing. Number 1, the forming of ceramic products. Forming by plasticity is the oldest method of forming ceramics. The clay body is prepared by mixing clay with other raw materials and kneading it thoroughly, or it may be mixed with water to create a slab and then filter into sheets. For example, hand building. This is the most free-form method of taping, where the craftsmen use their hands and various tools to shape the clay into the design. From this method allows for the creation of products in any shape. Tickering. This method is used in industrial setting where a clay sheet is placed on plaster mold and a blade is used to press and shape the clay into the desired form. It is typically used for round and flat products. Extrusion. In this method, clay is passed through an extrusion machine to produce long continuous shapes with a cross section designed to meet specific requirements. It is commonly used for products that have long uniform shapes. Number 2, slip casting. In this method, the clay body is prepared as a thick, well-flowing liquid clay. The slip is then poured into a plaster mold where the plaster absorbs the water, causing the clay to adhere to the walls of the mold and take on the desired shapes. This method allows for the formation of products in various shapes. However, it requires a large amount of water, leading to high shrinkage after drying, which can result in cracking or warping. Examples of products from using this method include complex or hollow shapes. Number 3, firing and glazing. Firing is a crucial process in the production of ceramic products. It is during firing that raw materials are transformed into a strong, stable body that cannot revert to its original state. Any error during the firing process can result in products that are broken, damaged, or of inferior quality. The raw materials for making ceramics: white or light cream colored clay, which is used as the primary ingredients in ceramic production. High quality kaolin has few impurities, a high clay content, and when fired results in a white color. Major sources of kaolin in Thailand include ระนอง ลำปาง อุตรดิตถ์ นราธิวาส อุดรธานี เชียงราย อุทัยธานี กาญจนบุรี ราชบุรี เพชรบุรี ปราจีนบุรี สุราษฎร์ธานี และนครศรีธรรมราช Next, bulk clay, also known as black clay, is sometimes referred to as dark clay due to its dark to blackish color. It has fine particles and when fired turns a white to light brown color. Ball clay is typically found in lowland areas and is characterized by its fine texture and the presence of organic matter. It has excellent plasticity, providing greater strength to unfired products compared to kaolin clay. The heating process of ceramics materials. 1. Calcination. It is the process of heating powder substance to cause materials decomposition, phase transformation, or to expel unwanted components of the precursor materials. 2. Sintering. It is a process of applying heat or pressure to a material causing the particles to form bonds with each other, resulting in a denser and stronger structure, and heat causes adjacent components to contract and bond together. This type of heating helps make the material tougher and less brittle. 3. Annealing. It is a process of heating materials to enhance their physical and chemical properties, making them more suitable for use. This may result in increased flexibility, reduced stress, clearer crystallinity, greater homogeneity, and improved resistance to fracture. Types of ceramic products. Ceramic products can be classified into various types, but the most important are two main types. Number 1. The classification of ceramic products based on their functional applications can be divided into 5 groups as follows: tableware, souvenir and decorative items, floor tile, wall tile, and mosaic sanitary insulator. Types of ceramic products. 2. The classification of ceramic products based on their physical and chemical properties can be divided into 3 types as follows: earthenware, stoneware, and porcelainware. Benefits of ceramic products. Number 1. Durability. Ceramic products are highly durable and resistant to wear and tear. They are able to withstand extreme temperatures, making them ideal for use in both high and heat environments like ovens and kilns and cold climates. 2. Heat resistant. Ceramics are excellent insulators with a high resistance to heat, making them suitable for use in cookware, tiles, and other products that are exposed to high temperatures. 3. Chemical resistance. Ceramic materials are resistant to the most chemical, which makes them ideal for use in environments where they are exposed to harsh substances, such as in laboratories or industrial settings. 4. Electrical insulation. Many ceramics are excellent electrical insulators, making them suitable for use in electronic components, insulator, and other electrical applications. And the last, number 5, aesthetic appeal. Ceramic products come in a variety of colors, texture, and finish, making them popular in home decor, art, and architecture. They are often used in tiles, pottery, and decorative objects for their visual appeal.
Nuclear fuel product. The meaning of nuclear fuel. Nuclear fuel refers to material used as the source of thermal energy in nuclear power plants. The heat generated comes from fission reaction, which transfer heat to cooled water for electricity generation. And no fossil fuel, nuclear fuel is distinct in its origin to use. The primary fuel of nuclear energy is uranium, which is radioactive element commonly found to Earth. Mined uranium is then processed into nuclear fuel generate heat through the process of nuclear fission, unlike conventional fuel, which produce heat through combustion. Additionally, nuclear fuel has the following distinct characteristics. It maintains its physical state both during and after use. The fuel does not deplete immediately after its first use and can potentially be reprocessed during the fission reaction. Also, elements that can be used as fuel, such as plutonium-239, are generated. There are no external waste emission because the heat is processed through nuclear fission, so there are no source smoke or gas released into the atmosphere. Nuclear fuel. 1. It uses nuclear fuel fission to produce heat without emitting soot, smoke or gas into the atmosphere. 2. A 1000 MW power plant requires approximately 30 tons of fuel per year. 3. Fuel peaks remain stable because in one operating cycle, about one-third of the total fuel in the reactor is used. Compared with approximately 1.5 times the reserve fuel is allowed operation for at least 4 recycles, which about charging the full cost. 4. Specialized technology is required for fuel production. 5. The spent fuel is contained within fuel rods and even after use, it maintains its physical state. 6. The food becomes high level radioactive waste which requires specialized technology of management about occupy relative little space. 7. The estimated global reserve of uranium, thorium, or approximately 600,000 tons across more than 30 countries. Extraction. Extraction is chemical process used to separate uranium ore from the mine material, as uranium ore is often mixed with other minerals. Enrichment. The uranium hexafluoride gas often must be enriched by separating uranium 238 isotope to increase the proportion of uranium 235 isotope from 0.7% to 34%. This concentration level is substantial and will convert UF6 back to uranium. Fabrication and assembly of full-loose uranium power is compressed into pellets resembling check sticks, which are diameter of about 1 cm and a range of approximately 2 cm. These pellets are then placed into tubes made of zirconium alloy, which are about 4 meters long. The zirconium alloy tubes have high resistance to pressure, heat, and corrosion, and importantly have low Newton absorption property. Energy production. The energy production from nuclear fuel occurs through nuclear fission. This involves bombarding the nucleus of uranium-235 with low energy neutron, causing the neutron to split and release an immense amount of thermal energy greater than 200 million electron volts. This process also generates neutron, which can initiate further chain reaction. Nuclear energy can be classified into 4 types based on nuclear reaction as follows. 1. Fission energy. This refers to energy generated from the splitting or breaking apart of proton and neutron in the nucleus of heavier element. 2. Fusion energy. This refers to energy produced from the fusion of a nucleus of like elements such as hydrogen and helium. This process, known as fusion, generated tremendous amount of energy. 3. Nuclear decay energy. This refers to energy resulting from the decay radioactive substance or elements such as uranium, radium, and plutonium. These elements release radiation and virus particles during their decay process. Fuel management. After being full load are swapped, which author load earlier. The load in the reactor core are removed and replaced with those from the auto regens. Typically, loads that have been used for about 3 to 4 years are replaced with new full loads. Advanced mathematics is employed in this fuel management process to optimize the fuel cycle, and the method not of application to auto type of fuel. 1. Spaceful staying. Temporary staying of spaceful invalid keeping used fuel within the power plant area or through nuclear fission reaction stop when the reaction is shut down. Heat continues to be generated from the fuel due to the beta radiation decay of fission product. 2. Reprocessing. Reprocessing of spaceful invalid turning useful that contain uranium-235 plutonium isotope formed in the reactor core and uranium-238 excluding uranium-238. About 95% of the regional uranium, which is uranium 235 radium in the space fuel in the Europe and Russia. Depositing is carried out to the space uranium and plutonium from the waste, allowing them to be recycled and used again in the nuclear reactor. The final dispersal. After the reprocessing of space fuel, the remaining high-level radioactive waste is dirt until it becomes a dry solid. This process is called calcination. The radioactive waste is then melted into a homogeneous gas-like material using very high temperature. The resulting material are poured into stainless steel or copper container and then stored. Specific considered to be of the highest safety standard. Use of nuclear energy in medicine, in industry, and in agriculture. Leaks of nuclear energy. Issue related of nuclear energy includes the location and method for storing space fuel or nuclear waste, which remain hazardous due to their radioactivity for thousands of years. Many nuclear power plants are located on or near crossing lakes to have access to water for cooling, but they also face challenges such as rising sea level and the risk of severe osmosis due to climate change. Nuclear fuel products: uranium, plutonium, and thorium. Byproduct fuel. There are the product fuel resulting from the use of nuclear fuel in power plant and push high risk in environment due to their radioactive material and high heat. Delicate for handlings. An example of nanoparticle is spaceful from low enriched uranium, which is contains with him to oxide of fuel pools during operation with temperature cause the fission product to move. New and developing fuel. Composite fuel. Development of fuel that combine various materials to address problems associated with the use of fuel. Mixed oxide fuel. A type of fuel that mixes plutonium with uranium in the form of oxides for use in nuclear power plants.